All right. So let's use that information that we got from the warm-up. Okay, I guess I'll recopy it here just because, I guess. So let me do that here. So x sine of x cosine of x. Okay. If you don't want to recopy it, that's fine. I mean, you don't really need to. I'm just going to have it there so I can refer to it and stuff like that for the video and all that jazz. Okay. So anyway, sine of 0 was 0. Then we had 1/2. Then we had root 2 over 2, which we said is about 0.7. Then we had root 3 over 2, which is about 0.8. And then pi over 2 is 1, 0. -1, and 0. Okay? I'll just focus on the sine for right now. Okay? So, let's graph this, right? I mean, this is essentially a table of values, right? Where we have our x values and then paired up with y values where y is just equal to the sine of x. So these are like all coordinate pairs right here, right? So we could graph these. And so what I'm going to do is we'll graph them. So let's graph y equals the sine of x. Okay. Now, one moment. Hello? Hello? Yes. Yes. Mm-hmm. Oh, okay, yes, I know, yes. Bye. All right. Drew, they want you up in the front office and you're supposed to take your things with you too. I guess you missed a test or something like that, so very exciting. All right, so anyway, back to graphing here. Y equals the sine of x. So, like I said, we're going to graph this thing. Look at your y values there. What does it look like when I go to like set up my graph here? What does it look like the highest y value we see here for sine of x? What's the highest y value we see for sine of x? 1, yeah. What's the lowest y value we see? -1, okay? So when I go to set up my y-axis here, when I go to graph this, I'm going to put my x-axis right in the center. Okay, let's 0 there. I'm just going to go up to +1 and then down to -1, just like that. Okay, because it looks like the highest y value for sine, right, was 1, and the lowest y value is -1. Right? 1, -1. All right? And then, when it comes to the x-axis here, well, we started at 0, so we'll have it start at 0 here, okay? And then we go all the way out to I went all the way out to 2 pi, okay? And I kind of went out to 2 pi because, remember, if you think about, like, angles, right, 2 pi is the same as how many degrees? Do you remember? 2 pi is the same as how many degrees? Anyone remember? 2 pi radians is the same as how many degrees? What's that? 90? 90 is pi over 2. So 2 pi is actually one full rotation. Okay, 2 pi is one full rotation there around the circle. So this is like the same as 360 degrees. Okay, so we kind of like, in other words, we kind of start to repeat after 2 pi, right? 2 pi is in the same position as 0. Okay, so we went out kind of one full rotation there. It's going to just start to repeat after that. Well, you'll see anyway. Okay, you'll see, I think, once we get the graph down. All right, so let's just go ahead and plot some points here. So 0, 0, that's an easy one. Okay, I'm just going to say let's go all the way out to here, and I'll say that's 2 pi right there. Okay, and then I'll do some like halfway points. So let's see, halfway between 0 and 2 pi, well, that's going to be pi. right? Halfway between 0 and 2 pi is just going to be pi. And then halfway between those two, we'll have pi over 2. And then here, halfway is going to be 3 pi over 2. Okay. So again, between 0 and pi, halfway is pi over 2, right? Because you just add them together. 0 plus pi is pi. Divided by 2 is pi over 2. Add these two together. Pi plus 2 pi. Well, 1 pi plus 2 pi is 3 pi, right? Divide by 2 to get the halfway point, and there it is right there. Okay. All right. So we have 0, 0. Now, pi over 6 is going to be in between the 0 and pi over 2 here. So I'm just going to say, like, roughly, like right there. And at pi over 6, we're at 1/2. So I'm going to go halfway up to, like, right there. Okay. Pi over 4 is exactly in the middle between 0 and pi over 2. And at pi over 4, we're at 0.7. So I'm going to go up a little bit more, but not quite 3/4, so something like that. And then pi over 3, we're at 0.8. And we'll say pi over 3 is like right there, and 0.8 is a little bit higher still, a little bit more than 3/4 of the way. And then pi over 2, we're at 1. Okay, now let's just connect these dots right here. So there's the first part of our curve, from 0 to pi over 2, or from 0 degrees to 90 degrees, if you like. Okay, from 0 degrees to 90 degrees, if you like. Okay. Questions on anything so far? Questions on anything up to this point so far? So far, so good? Okay. Again, this is pi over 6 right here. There's pi over 4. There's pi over 3. Just just roughly, estimating. And then pi over 2 is at 1. All right. And then after pi over 2, well, I kind of skip a bunch of points here, right? So there's a bunch of points between pi over 2 and pi, but I'm just going to skip to pi over 2. Sorry, pi, which is at 0. So now what do you think? We went from 0, we went up to 1 at pi over 2. Now we have to get back down to 0. So we're just going to create a similar kind of shape here. Okay, a symmetric kind of shape like that. Okay. And then at 3 pi over 2, what's our y value at 3 pi over 2? -1. So 3 pi over 2, I should be down here at -1. And so we'll just kind of continue to connect that. And then at 2 pi, what's our y value? 0. So we go back to the x-axis here. Okay. And there's our curve. Now, what do you expect to happen here if we were to keep going? What would happen here if we kept going? Yeah, exactly right, Haley. It's going to be like a wave. Okay? So yeah, we're going to keep kind of, and I'll just go ahead and extend it out here. Okay? So let's see here. 0 to 2 pi, and if I wanted to keep going, well, I'll go 2 pi out to then 4 pi here. And so that makes this 3 pi, and this will be 5 pi over 2. And then this will be 7 pi over 2. Okay? And so, yeah, it's going to look something like this at 5 pi over 2. So, well, you tell me. So at 2 pi, right, we kind of like have repeated, right? We've made one full kind of wave here. At 5 pi over 2, okay. Okay. So if you look at the kind of pattern here, after 2 pi, right, comes 5 pi over 2. Where are we going to go? What value should we go to? Yeah, 1, right? Follow the pattern. So it should go back to 1 here. And then at 3 pi, where should we be at what y value? What do you think? Just follow the pattern. Where? 0, yeah. And at 7 pi over 2, where are we going to end up? -1. Yeah, you got it. And then at 4 pi? So that's what we got. Right, I'll reconnect the dots here. Where will it be at 4 pi? Back to the 0, right? So you guys see the pattern there, right? For sine, we start at 0 on the x-axis, we go up 1, back to 0, down 1, back to 0, up 1, back to 0, down 1, back to 0. Okay? Just like that. Now, and of course, it's going to keep going. Sine continues to go here. Right? So I'm going to put some dot, dot, dots and maybe some arrows to show that it keeps going. Okay? What is the domain of sine going to be here? What's the domain of sine? What's the farthest left our graph is going to go here? 0, but remember it keeps going, so it's going to actually go to negative infinity. Okay? What's the farthest right our graph is going to go here? Positive infinity. You got it. Okay? What about the range? What's the lowest y value we're going to have here? Negative 1. And we're going to include negative 1 because we do get to that, right? And what's the highest y value you get to here? 1. 1, yeah. Okay, so there's our range. And again, we do get there. Okay. Now, this function, okay, it's periodic because it repeats itself every so often. Okay? What is the width of the period, or how often does it repeat itself? Every what? What's the width of one full wave here? Or how often does it repeat itself? Every how many units? Every two what? We start at 0, we go out to 2 pi, and it repeats itself, right? At 0 and at 2 pi, right, they both go up, and then down, and then down, and then back up. And now we start over at 2 pi and 4 pi. So what's the width of this period here? How often does it repeat itself? Every what? 2 pi. Every 2 pi it repeats itself. Okay? So let me kind of like do something like this. Okay? So we'll do it like this, right? So, okay, one full period of the wave there is 2 pi. It repeats itself every 2 pi. Okay, this function is called periodic, okay, because it repeats itself on a regular interval. Okay. We can also, you might remember this from like science class too. This is called like the wavelength, right? The length of the wave, right? From starting point of the wave to stopping point of the wave, okay, or to where it repeats, right? So one full wavelength there, or is one full period, which is 2 pi. Okay. We can also talk about the height of the wave. Do you guys know what the height of a wave is called, or what the word is we use to refer to the height of the wave? Starts with an A. Have you guys talked about waves before? In other science classes or anything like that? Yes, no? Amplitude. Amplitude. Okay, amplitude. What is the amplitude of this wave? 1. Okay, amplitude is 1. If you're a musician, right, and you play like electric guitar, right, you plug your guitar into an amp, which is short for amplitude because or I think maybe it's amplify, but the idea is the same, okay? It increases the height of the wave, the sound wave, and that's what makes the, music louder, or you decrease the amplitude of the wave and makes the music softer, right? Okay. Okay. So those are different pieces here of that sine function. Okay. Questions on any of this right here? All right. So I will also show you cosine. All right. It's not quite as exciting as sine was because sine was brand new to us. Okay. But I'll go ahead and do cosine here too. So cosine, let's see here. Cosine was at 1 there. It's at root 3 over 2, which is approximately 0.8. And that root 2 over 2, which is approximately 0.7. Ugh. And then pi over 3, which is going to be 1/2. And then 0, and then negative 1, and then 0, and then back to 1. Okay, so let me show you cosine.
That's called
amplitude. Amplitude. A-M-P-L-I-T-U-D-E. Amplitude. Right? I'll do the same thing here with cosine. I'm going to try and line things up similarly. Okay, because you can see here for cosine, right? What's the highest value cosine has? What's the highest y value cosine? 1. What's the lowest value for cosine? Negative 1, yeah. So we're going to have a similar range. Okay. I'll put the 0. And again, I'm going to go from 0 to pi or 2. I'm going to try and or 0 to 2 pi. So I'm going to try and line things up just like I had up there. So there's pi, I'll say. Pi over 2, I mean there's pi. Just so we can kind of compare the two graphs. Okay. So again, let's graph this. So cosine of 0 starts at 1. Cosine of pi over 2 is at, cosine of pi over 2 is at 0. Okay, I'm going to kind of skip the pi over 6, pi over 4, pi over 3 stuff. I think you'll get the idea. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. Cosine of 2 pi is back at 1. So we're going to look something like this. Okay, just like so. And of course, if we go out to you can see the pattern here too, right? How it's kind of going to repeat itself. Is it the exact same graph as sine? It's not the exact same graph, but it's pretty close, right? Are we still going to have a wave here? Yes, we are, right? We're still going to have a wave, but it's not the exact same graph of cosine, or of sine, but it's pretty close. So if I were to just continue the pattern here, right, at 2 pi, we kind of peaked up at 1. So at 5 pi over 2, where do you expect the graph to be next? Yeah, back to 0, right? Just follow the pattern, right? When we're at a peak, we go back down to 0, and then from 0, we go back down to negative 1, and then back up, up, and then down, down. So we go to the 0, and then at 3 pi, we should be down at the negative 1 there. 7 pi over 2 back to the 0, and then at 4 pi back to the 1. So we'll just kind of connect those dots. Okay, just like that. And of course we could continue from there. What's the domain of cosine going to be? What's the domain of cosine going to be? Negative infinity to infinity, yeah. Okay. What's the range of cosine going to be? Well, what's the highest y value? What's the lowest y? Well, sorry. What's the lowest y value for cosine? Negative 1. And what's the highest y value for cosine? Yeah, just 1. Okay. Does it have, what's its period? It repeats, right? What's its period? What's one full period? What's the length of that one full period? How often does it repeat? Every how many units? Same answer to all those questions. Oh, what's that? Okay, every 2 pi radians. Every 2 pi radians. Yes, exactly. From 0 to 2 pi, right, it repeats itself. At 0, it starts up, goes through one full wave, and then 2 pi, it starts to repeat itself. And then 2 pi later, at 4 pi, right, it gets back up to the peak again. So again, we have one full period, 2 pi. just like that. What's the amplitude of this wave for cosine? What's the amplitude? What's the height of the wave? It's 1, right? It's 1. Okay, so amplitude's also 1. So, sine and cosine both have they repeat every 2 pi. They both have an amplitude of 1, so that means they both go up 1 and down 1 from their center, right? Their domain and ranges are the same. But they're not the exact same graph. What could we do, though, to make them the exact same graph? What kind of transformation could we do here? Does anyone see? What kind of transformation could we do here to make these 2 graphs kind of match up perfectly? Any ideas? You can be, as general as you want, I guess. What kind of transformation could we use to match these 2 things up? Well, do we need to shift things up or down at all? No, we don't need to shift it up or down, right? They're both kind of in the right, right height, I guess we'll say. Do we need to vertically stretch or shrink at all?
Is it a reflection?
Is it a reflection? Good question here. Let's see if I could, reflect this. Let's see. It's not quite a reflection, I don't think, because, if you look here, right, we'd have this full peak right here, and if I reflected that, we'd have then that full peak would be, over here, right? But if you look down here, if I put the full peak right down there, it wouldn't quite line up because the peak's there. You see what I'm saying? It doesn't quite work out that way. Not a reflection, no. Or if we reflected it over the x-axis, right, from pi over 2 to 3 pi over 2, we'd go up. But here, from pi over 2 to 3 pi over 2, we kind of go down, and we go down the whole time, I guess, kind of thing. Well, we go up and down, sorry. But here we just go down the whole time. So it's not quite that. Any other ideas about what the transformation might be here? Mike?
Like a translation of 1.
Okay, translation, which direction? Up, you're saying?
Yeah.
If we translate everything up 1, well, let's see here. If you're saying, if I take this one and shift it up 1?
I thought you were asking the difference between.
Yes, I am. How could you make one match the other? I am. Yep, exactly right. What I'm asking. Not sure. Okay. Yeah, it's not a translation up 1. Nope. Any other ideas? Cheyenne? No. Okay, you're saying a stretch. Stretch which direction? Horizontally. Okay. If we stretched it, so right now, if we stretched it. We already have, the full period here is 2 pi, the full period here is 2 pi. If I stretch that, now my wave is going to be elongated, right? So the period won't be 2 pi, but these should both be 2 pi. We want them to stay the same. So you're on the right direction, though. We do want to do something horizontally here, but we don't want to stretch it horizontally. What do we want to do? Not a shrink either. We want to shift it horizontally, okay? Okay, so we want to move it left or right here. Can you tell how much? I'll give you a hint, right? Look at the peak here, right? And look at the peak here. Notice where they occur, right? How much do we need to shift by? By one of those things. What is the measure of one of those things? It's at pi over 2, right? So if we can take this and shift it left pi over 2, we will have moved this whole wave back to right there, right? Or if we take this wave and we shift it right pi over 2, right, then the peak will now be over here and it will match up perfectly. Everything will match up perfectly. Okay, and I can show you that here in a second if you on Destos and something like that. Okay. So, questions on any of that? So, let me then also talk about some transformations. Since we're talking about transformations here, so once again, we're talking about these, transformations and stuff like that. Okay. When we have a number in front of our function, how does that affect the function? You guys remember? What does the coefficient in front of our function do? What kind of transformation does that result in? A stretch or a shrink, that's right. Okay, yes, a stretch or shrink. So A, vertical stretch / shrink. Okay, which, by the way, if we stretch or shrink this thing vertically, the amplitude is going to be affected, right? If we stretch or shrink vertically, right, that's going to affect our amplitude. It's going to affect our wave height here. So that the A is exactly the amplitude. So I'm going to put that here too. Absolute value of A equals amplitude. Okay, the absolute value of A is the amplitude. All right, what's well, we didn't do too much with B. B is a horizontal stretch or shrink. Okay. What does what's C going to do? That plus C on the inside with the X. What does C do? When you add or subtract a number to the X, what does that do? It's going to what? Left or right? Yeah, shift left or right. Okay, and then what's D? Plus D on the outside. What's that going to do? Shift it up or down, yeah. Okay, just like that. Question? Mm-hmm. Okay, so let's take a look at one or two more here. Ooh, I lost the paper. That's okay. Okay, so let's graph one or two more here. Okay. So again, all we're going to be doing today is just graphing. Okay, so let's graph this first one here. We'll do y equals 2 times the cosine of x. Sorry, some people still writing that.
So if I,
Yeah.
I know that.
Sure. Okay. So y equals 2 times the cosine of x. Okay. So what's that 2 in front going to do? Okay, yeah, vertical stretch, right? In other words, our amplitude is not going to be 1 anymore. Our amplitude is now going to be what? 2. So instead of going up to 1 and down to -1, we're now going to go up to 2 and down to -2. And that's the only thing that's going to change, really, about our cosine graph. Okay, so let's see here. Okay, so and I'll just graph, let's see here. I'll just graph one full period. Okay. So, we still start at 0 here. Okay. Because we didn't, you can see in here there's no transformations. We're not shifting anything left or right. We're not shrinking anything or stretching anything. horizontally, but we are going to stretch or shrink vertically here because of that 2. Okay. So we'll make 2 be our highest y value there, and then negative 2 be the lowest y value, again, because of that amplitude there of 2. We're going to go up 2 and down to negative 2 now. Okay. Trying to think, let's see here. So, since we didn't stretch or shrink horizontally, right, we're still going from 0 out to 2 pi here, okay? 0 to 2 pi will give us 1 full period. So, I'm just going to go out here and say there's 2 pi. Okay? And that gives us 1 full period. And I'm going to go ahead and just find the midpoint here. So the midpoint between 0 and 2 pi is pi, and I'm going to find the quarter points. Okay, just like so. Okay. Okay, so this is how we're going to be graphing things by hand. Okay, you're going to find the starting point of your period, which since we didn't shift left or right, it's going to be 0. Okay, you're going to find the ending point of your period, which again, because we didn't shift left or right or stretch or shrink horizontally at all, it's going to end at 2 pi later. Then you're going to calculate the midpoint, okay, which you can do a couple different ways here. I mean, here because we start at 0 and go to 2 pi, you can tell the midpoint just by, just finding the midpoint there. Or you can also add these two numbers together, 0 and 2 pi, which is 2 pi, and then divide by 2, so pi, right? Same thing here. We're going to then find the quarter points. So add these two numbers together, 0 and pi, that's pi, divide by 2, pi over 2, all right? Add these two numbers together, pi plus 2 pi, well, that's 3 pi, divide by 2, 3 pi over 2, okay? And then at this point, it's your choice about what to do here. You can go to your graphing calculators if you want to, all right? And we can get the y values from those points. So I'll go to my y equals here. I'm going to type in 2 cosine of x. Okay, making sure I'm in radian mode here. Okay, so I'm going to type in 2 cosine x here to help me with the graphing. And again, I'm making sure I'm in radian mode as well, so make sure you're in radian mode there. Press the mode button, which is right next to the second button there, mode. Okay. And then go to our table. But the problem with my table, the problem with my table is that it only counts by ones. Right? I need like pi over 2, pi, 3 pi over 2, and 2 pi. Okay? So you can adjust your table if you press second window. Remember how to do this? I'm pretty sure I showed you guys this. Change your independent from auto to ask. Okay? This will allow us to type in our own x values that we want the calculator to evaluate for us. I go back to my table, it's empty because it's waiting for me to type stuff in. So now I can type in 0 and I get 2. So it's 0, 2. Okay? And then I'll type in pi over 2. Okay, at pi over 2, I'm at 0. That's easy enough. And then at pi, whoops, I got to go back here. At pi, negative 2. Okay. At 3 pi over 2, 0. And then at 2 pi, enter 2. Okay. And there's one full period of my graph. Just like that. Okay. So there's one full period of the graph with the amplitude of 2 and the period there is 0 to 2 pi. Okay, now let's say I wanted to get one more wave, right? Here's one full wave. let's say I wanted to do one more wave here, okay? Well, again, the wavelength, right, the period here is from 0 to 2 pi. So I would need to go out to what if I want to do one more full period here? 4 pi, right. Okay, and then again, I would want to find the midpoint. So the midpoint here would be 3 pi, because again, 2 pi plus 4 pi is 6 pi, divided by 2 is 3 pi. And find the quarter points. 2 pi plus 3 pi is 5 pi, divided by 2 is 5 pi over 2. And then 3 pi plus 4 pi is 7 pi, divided by 2 is 7 pi over 2. Okay, and again, you can just go to your graphing calculator here, and in your table, I'll go back up to the top here. I'll type in 5 pi divided by 2. Okay, which gives me a y value of 0. Which really should make sense because at 2 pi, if we're above, we should probably go back to the x-axis here. So you can kind of use the pattern too if you see the pattern, right? Where it's like, okay, at 5 pi over 2, we got to go back down to -2, right, for 3 pi. And if I type in 3 pi, you'll see it's -2, right? And then at 7 pi over 2, I should be back at the 0. And at 4 pi, I should be back above the x-axis there at the amplitude of 2. Okay, and of course it keeps going. I'm not going to ever ask you to do more than 2 full periods, but you should be able to do at least 2 full periods. Okay? You should be able to do at least 2 full periods there. Okay, question? Mm-hmm. All right. Any questions on that so far? All right, I'm going to do one more here. At least one more here. Actually, what? Maybe I'll just stick with amplitude stuff. Can I get away with that? Looks like I can. Okay. Let me do one more here. Let me do y equals 1/2 sine of x. Let me just do this for right now. Okay, we'll do one more here, and then I'll have you guys start on your assignment. Okay, today I think we'll just focus on doing amplitude. Tomorrow we'll talk about period, stretching, and shrinking. Okay, but today we'll just focus on amplitude. All right. Now in this case, okay, that 1/2 in front, what's that going to do? A shrink, yeah, a shrink. Okay, so maybe I'll make this like 1/2 right there. 1/2 and make it 1/2 like that, maybe. Okay. Is the period affected at all? Are we shrinking horizontally at all? Shrinking or stretching horizontally? Are we shifting anything left or right at all? Do we have any other transformations in here? The answer is no. We have nothing else. Okay, so it's just the vertical stretch or shrink there. Okay, so we'll still start at 0. All right, and of course sine and cosine, they both repeat every what? Radian measure. They repeat every how many radians? 2 pi. That's right. So again, I'm going to go, there's 2 pi, we'll say. Okay, so there's 1 full period, and we'll extend it to 2 full periods here in a second. Okay, let's just do 1 full period. Okay, so again, we have the starting point and stopping point of our period, and I'm going to find the midpoint of my period. So what's halfway between 0 and 2 pi? Pi. Okay, and let's also find the quarter points, right, or the halfway of the halfway. So halfway between 0 and pi, well, add them up. 0 plus pi is pi, divided by 2 is pi over 2. Okay, and then find the midpoint between these two. Well, pi plus 2 pi is 3 pi, divide that by 2 is 3 pi over 2. Okay, and now at this point we can go to our graphing calculator. 0.5 sine of x. Okay, you can see right there. So I'm just going to type in 1/2 or 0.5 times the sine of x. Go to my table. I'm going to delete out all those old values, and I'll do 0. Okay, so it's 0 where it's 0. Okay, and then at pi over 2, we are at 1/2. So pi over 2, 1/2, that's right there. Okay, and then at pi, back to 0. 3 pi divided by 2, negative 1/2. And then 2 pi, back to 0. Okay, and then just connect the dots. Like that. And there's one full period, one full wavelength, right, of the 1/2 sine x graph there. Like I said, let's go ahead and let's extend this out. Let's do 2 full periods just because we can. So again, one full wavelength is 2 pi, so I'll go another 2 pi out to 4 pi. And again, I'll find the midpoint at 3 pi. I'll find the halfway point here, the quarter point I should say, at 5 pi over 2. And then 7 pi over 2. Okay. And again, you guys might be able to get the pattern just by looking at the graph right there, right? So I could type this in my calculator in the table if I wanted to, but at 5 pi over 2, well, what do you expect to happen here? At 2 pi, we're at 0, and we're kind of coming up, right? So at 5 pi over 2, what y value should we get? 1/2, right? And so it's going to bring us up. And then from here, where do we go next? At 3 pi, we should be at what y value? Yeah, 0, right? You can kind of see the pattern, right? We got to go back down. And then at 7 pi over 2, we got to go back down again to the negative 1/2. That might be too low. And then 4 pi, back to the 0. And so we kind of just extend our wave there. Okay, it's going to keep going. And that's the graph right there. Questions on any of that? Okay. Let me give you guys your assignment then here. All right. The assignment is going to be out of, again, on a PDF. All right. I'm not going to use our online textbook. I just scanned another older textbook that we had that I'm going to use there. So again, it's from the Green Book, which is, I scanned the pages. And it's in a PDF on our Google Class. I'll put it on the Google Classroom here in just a second. Sorry, it's not quite there yet. 912 and 913. I want you to do numbers 3 through 5. And then numbers 7, 10, and 12. Okay, so these 3 are graphs. Okay, 7, 20, 10, 12 are graphs. Okay, so, yeah, I'll get this posted here in just a second.